Graph the piecewise function and find f of -4 and f of 4 if f of x is this piecewise function. Let's start with the top function, and we're going to plug -2 in. So when we plug -2 in here, we get 1 squared plus 1, which is 2. So we get -2, 2 as a point. Let's plug in -3 because we want values that are less than -2. So if we plug in -3, we get 0 plus 1, which is 1. So -3, 1. How about one more to see if we can find this? I think that's going to be the vertex right there. So we have -4 comma. If we plug -4 in, we get -1 squared is 1 plus 1 is 2. So now we're going back up. We did find the vertex of this parabola. And I noticed that I want this point right here to be an open dot because we don't have equal to. So we have this parabola right there. Then we have the square root of x plus 2. If we plug in -2, we get 0. So -2, 0. And we want that to be solid. And now this is this is a square root function. So the square root of 1 is 1. And you're like, square root of 1? Well, yeah, if you put -1 in here, -1 plus 2 is going to be 1. Square root of 1 is 1. And 1, 2, 3, 4 away will be the square root of 4, which is 2, 5, 6, 7. Well, we don't want to go that far. We only want to go to 4, which is the square root of 6, which is 2 point something. So I'm sure it's about right there. And we want that dot to be solid also. Now, once we get to 4, we're graphing y equals 5. 1, 2, 3, 4, 5. Open dot there, and all of those are going to be 5s to the right. F of -4, well, -4 is less than 2, so we're going to plug that into the top one. I already plugged -4 in, and we got a value of 2. And then we plug 4 into this the middle one, because that's where the equal to is. And 4 plus 2 is 6, so we get square root of 6. Number 2, we're graphing the square root of x plus 3 plus 1. Well, the parent graph is the square root of x. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So that'd be right there. Plus 3 is on the inside of the function, so this is left 3. And on the outside, we have a 1, a plus 1, so that's up 1. Left 3 and up 1. That's right there. 1, 2, 3, up 1. 1, 2, 3, up 1, and 1, 2, 3, up 1 would be right there. So here is our square root graph, and it'd keep going like that. 2 means it is a well, actually on the outside it'd be vertical stretch. On the inside, it's a horizontal shrink by 1/2. So we have half. This is going to go to 1. That's going to go to 1. This is 3, so this will go to 1.5. So how about those? And then on the -3 on the inside is right 3 units. So we're going to take all these 1, 2, 3 here. This one moves over 3, and then here, and then this one, and then we got here, here, and here. So this is the final graph right there. I missed a little bit. Number 4, graph the rational function. Let's factor x plus 1 over x plus 2, x minus 2, and we don't have the same factor on the top and the bottom, so that means there's no holes. X-intercepts, that's what makes the top 0. So -1, 0 is the x-intercept. Y-intercepts, we plug 0 in for x, so that's going to be 0, -1/4. Vertical asymptotes is what makes the denominator 0. So we have x is equal to plus or minus 2. And horizontal asymptote, well, that's a relationship between the top and the bottom powers. We have a bigger one on the bottom, so that's an automatic y equals 0. If you have x squared on the top, then you don't have a horizontal asymptote. We'd have a slant asymptote, and we'd have to do long division. If they're the same, then it would be y equals 3/4 in this case. Let's plot what we have. -1, 0, we got that. 0, -1/4, that's about right there, let's say. Vertical asymptotes at plus and minus 2. So let's plot those. Like that. Horizontal at y equals 0. Ooh, boy. That is the x-axis. And the graph must do something like this because I don't have another x-intercept. So it curves like that. The domain, no, I haven't finished graphing this. We don't have any points in this little region and no points in that region. 1, 2, 3. How about -3? -3, comma. How about we plug it in here? So -2 over -1 times -5. That's going to be -2/5. So -2/5 is somewhere down here. And we have that action right there. How about plugging in 3? So if we plug in 3, we get 4 over 5 times 1. So 4/5. So positive 4/5. That's about right there. And then we're going to follow these asymptotes right here. Like that. The domain is -infinity to -2, -2 to 2, and 2 to infinity. We got to skip over those asymptotes. The range is -infinity to infinity, mainly because of this middle piece right here. This covers all of the y values. Ending behavior, we have the limit as x approaches plus or minus infinity of f of x is equal to 0. So on the ends, this graph is leveling out to 0. Number 5, we have an exponential function. The parent graph is 3 to the x. So 3 to the 0 is 1, 3 to the first is 3. 3 squared would be all the way up here at 9. And so we have this exponential shape. We're going to reflect that over the x-axis. 1, 2, 3. And the 9 would go all the way down there. Then right 1 and up 2. So right 1 and up 2. Right here. Right 1 and up 2. Right 1 and up 2. Well, that horizontal asymptote now has moved off of the x-axis. There's the asymptote. And we got this exponential curve right here. Should be a nice smooth curve. There we go. The domain is -infinity to infinity. The range is -infinity to 2. And the asymptote is up there at y equals 2. Natural log of x plus 5. Well, the parent graph is a natural log of x. And we have the point 1, 0. And then 2.718, almost 3, is a power of 1. And logs curve like this, like that. So we have 2 points to go off of. We're going to stretch vertically by a factor of 2. So that 0 stays. This 1 goes to 2 up here. And then left 5. So 1, 2, 3, 4, 5 right there. And we have this vertical asymptote that moved off of the y-axis. This one also moved 1, 2, 3, 4, 5. And this is being stretched vertically, so it's not quite as flat as the parent graph. The domain is -5 to infinity. The range is -infinity to infinity. And the asymptote is at x equals -5. Number 7, find the maximum and minimum values of the objective function and for what values of x and y they occur subject to the given constraints. So this is the objective function. Here we have, this represents the first quadrant where x and y are both positive. X plus y is equal to 7. So we have a y-intercept of, or x-intercept of 7 and a y-intercept of 7. And we have this line right here. And then we have an x-intercept of 9, 8, 9. That'd be about right there, I suppose. And a y-intercept of 6. 1, 2, 3, 4, 5, 6. And we have this line right here. Now, both of them are less than. 0, 0 work for both of them. So it's underneath like this. And I think I missed a little bit. I think it should be like this if I remember right. I think that's the intersection point. If I had a ruler, if I would have gone with straight lines and we would have extended the graph a little bit, that would have made it a little easier. But we have 7, 0 for a point, 7, 0 as a vertex of the feasible region. We have 3, 4. Is it 3, 4 or 4, 3? That's 6 plus 12. Yeah, that's it. 0, 6, and 0, 0 as points. And we really need to check that one. 6 plus 12. Yeah, that's 18. So 7, 0. Now we're going to plug these into the objective function. We get 14 for that one. 3 times 2 is 6. 5 times 4 is 20. So 26 there. 6 times 5 is 30. And of course, we're going to get 0 here. Now here's the answer. We have a minimum of 0 at 0, 0. We have a maximum value of 30 at the point 0, 6. Graph each system of inequalities. This is a circle, this is a line. So let's get the center of the circle, which is 1, negative 3. 1, 1, 2, 3. And a radius of 4. We're going to go right and left 1, 2, 3, 4. 1, 2, 3, 4. Up 1, 2, 3, 4. And down 1, 2, 3, 4. And I don't even want to attempt a circle with this. I'm using a tablet to do this. Let's see, where would the corner be? Right there? Oop, that ain't it. It goes from the center. All right, we're going to do the center, and here we have the circle. Now, if we check the point 0, 0, we have, if I plug 0 in here, we get 1 plus 9 is less than or equal to 16. So 10 is less than or equal to 16. That's true. So we're going to shade inside the circle. Let's get the line now. We have an x-intercept of 2 and a y-intercept of negative 5. 1, 2, 3, 4, 5. And we want a dotted line because it doesn't say equal to. And now we're going to shade inside. Oh, I should tell you that if I plug 0, 0 in here, 0 is greater than 10. That's false. So we want to shade on the opposite side. Nine, graph each conic, identify the key characteristics. This is a parabola, and we have x squared plus 8x plus something is equal to negative 4y minus 8 plus something. 8 divided by 2 is 4. 4 squared is 16. We got 16 here as well. X plus 4 squared is equal to negative 4y plus 8. So x plus 4 squared is equal to negative 4y minus 2. So the vertex is 2, negative 4. 2, negative. I think they're asking this down here. Here we go. 2, negative 4. 1, 2, 1, 2, 3, 4 right there. And then the focus is going to be 1 down because x is being squared. So 1 down here, and we have our directrix right there. So the focus is 2, 1, 2, 3, 4, 5. 2, negative 5. The directrix is y is equal to negative 3. And through the focus, we can go 2, 1, 2 to the right and 2 to the left. And then we try to draw what resembles a parabola. Here we have a hyperbola. We have x squared minus 4x plus something, minus 4 times y squared minus 6y plus something. It's equal to 36 plus something minus something. So that's going to be 4, so we're adding 4. This is going to be 9, so that's going to be minus 36. X minus 2 squared minus 4 times y minus 3 squared is equal to 4. And we're going to divide by 4. That's going to be y minus 3 squared over 1. We don't have to put that, but it's over 1. The center is 2, 3. 2, 3. 1, 2, 1, 2, 3. There's the center. We're going to go right and left 2. Up and down 1. And then we have this rectangle. We make the diagonals. Make the diagonals. Here we go. Those are going to be the asymptotes. That's going to guide the hyperbola. And since x is the positive term, that means this hyperbola is going right and left. Right and left. The foci, if you go c squared is equal to 4 plus 1. So c is equal to plus or minus the square root of 5. So now we would go right and left the square root of 5 from the center, which means we're changing the x. 2 plus or minus the square root of 5, 3. That's the foci. Now the asymptotes, we're going to use the center for that. So y minus 3 is equal to plus or minus. And we go up and down 2 and, up and down 1 and right and left 2. So up and down 1, right and left 2. So there's the slope. And we end up with x minus 2 for the asymptotes.